Try to tickle yourself. Use the same fingers someone else would use. Touch the same part of your body. Change the speed. Change the pressure. Move unpredictably. Almost nothing happens. You may feel your fingers moving across your skin. It may even feel slightly irritating, but it rarely creates the same helpless, laughter-filled reaction another person can trigger almost instantly. And that is strange. The skin is the same. The nerves beneath it are the same. The movement can be almost identical. So why does your brain treat the two touches as completely different experiences? The obvious answer is surprise. Another person can move in ways you cannot predict. You know what your own hand is about to do, so the sensation loses its power. That sounds right, but it is only half the story, because your brain does not simply recognize your touch after it happens. It predicts the touch before it arrives, and then it quietly turns the sensation down. Imagine reaching for a glass of water. It feels simple. You decide to move. Your hand reaches forward, and your fingers close around the glass. But before your hand gets there, your brain must solve a series of problems. Which muscles should move? How much force should they use? How far should your arm travel? When should your fingers close? And what should all of that feel like? When your brain sends a command to move, it also appears to create an internal copy of that command. Scientists often call this an efference copy. One signal travels toward the muscles and says, move. The other remains inside the nervous system and says, this is what that movement should feel like. Using this information, your brain predicts the sensory consequences of the action. Where will your hand go? When should contact happen? How intense should it feel? Then the real sensation arrives, and the brain compares it with the prediction. If the two closely match, the sensation is reduced. This is called sensory attenuation. The touch still reaches your skin, your nerves still send the signal, but your brain treats part of it as information it already expected. That is why your own touch feels weaker. Your fingers are not necessarily producing the wrong movement. Your brain has simply explained the sensation before it arrives. Researchers have tested this using machines. In one kind of experiment, a person moves one hand while a device transfers that movement into a touch on the other hand. When the movement and the touch happen at nearly the same time, the sensation feels relatively weak. The brain recognizes the sequence I moved. Then I felt what I expected to feel. But when researchers introduce a small delay, the experience changes. The hand moves first. The touch arrives a fraction of a second later. Now the prediction no longer fits perfectly. The brain expected. Now. Reality answered, not yet. That tiny disagreement can make the touch feel stronger, more external, and sometimes more ticklish. Researchers can also alter the direction of the movement. Your hand moves one way, but the device touches you in another. Again, the prediction begins to fail, and the sensation becomes harder for the brain to dismiss. This tells us that the brain is not simply checking whether the touching hand belongs to you. It is predicting the result of the movement. The timing matters. The direction matters. The location matters. Change those details, and an action you created can begin to feel less like your own. The system can even adapt. If the brain experiences the same delay repeatedly, it may begin learning the new timing. What first felt unexpected gradually becomes predictable. The brain updates its model. Then, when the delay is suddenly removed, the immediate touch may briefly feel wrong. The prediction system has already adjusted, so your brain is not following one permanent rule. It is constantly recalibrating, constantly asking, what should happen when I move, and does reality match? This is why the simple explanation you cannot tickle yourself, because you know it is coming, is incomplete. You can know someone else is about to tickle you. You can see their hand approaching. You may even know where they are going to touch. And your body can still react. Conscious knowledge is not the same as motor prediction. When another person moves, your brain does not have access to the command that created their movement. It can guess what they will do, but it cannot predict them with the same precision it predicts you. Their timing may change. Their pressure may change. Their fingers may move somewhere unexpected. That uncertainty is what your own hand cannot naturally recreate. But why would the brain turn down sensations produced by your own movement? Because your body creates sensory information constantly. Your feet press against the floor. Your tongue moves inside your mouth. Your eyes shift. Your clothes slide across your skin. Your chest rises as you breathe. If every predictable sensation demanded equal attention, your own body would become a constant source of noise. So the brain appears to reduce what it already understands. It gives greater importance to what has changed. Your own hand brushing your arm is usually unimportant. Something else brushing your arm might not be. One is the expected result of a movement the brain just ordered. The other might be an insect, another person, or something moving nearby. The nervous system must separate those possibilities quickly. Tickling exposes that system because the difference becomes impossible to ignore. The same skin can receive a similar touch, but one sensation is softened. The other breaks through. That does not mean scientists have completely solved tickling. They have not. A light, crawling sensation caused by a feather is not necessarily the same phenomenon as the intense social tickling that produces squirming and involuntary laughter. Scientists are still uncertain why some body parts are more ticklish than others. They still debate why intense tickling causes laughter. And laughter does not always mean enjoyment. Someone can laugh while also desperately wanting the experience to stop. Context matters. Trust matters. Who is touching you matters. So the complete purpose of ticklishness remains uncertain. But the failure to tickle yourself reveals something more fundamental. Your brain is not a passive machine waiting for the world to arrive. It is a prediction system. Before you feel the result of an action, your brain has already estimated what that result should be. Then it compares prediction with reality. A close match can be reduced. A mismatch becomes important. You normally do not notice this process. You do not feel the prediction being made. You do not feel the comparison happening. You only experience the final result. Your own touch feels familiar. Someone else's touch feels different, and this difference may help create one of the most basic feelings you have, the feeling that an action belongs to you. When you move your hand and the expected sensation follows, the brain has evidence that the event was self-generated. The command and the consequence fit together. But when a sensation arrives without the matching prediction, it feels external. Something touched you. Something changed outside your control. The boundary between you and the outside world feels obvious, but your brain must construct it continuously. Movement by movement, touch by touch, prediction by prediction. And a failed attempt to tickle yourself exposes the machinery. You place your fingers against your skin before they move. Your brain sends a command. From that command, it predicts the contact. The touch arrives, the prediction matches, and the sensation is quietly reduced. So you cannot easily tickle yourself, not because your fingers are too weak, and not simply because you consciously know what is coming. You cannot tickle yourself because your brain has information no outside person has. It knows what you are about to do before you do it. It prepares for the result, and it edits what you feel accordingly, which means the world you experience is not a raw recording delivered directly from your skin. It is partly shaped by what your brain expected to happen. Someone else as fingers remain uncertain. Your own hand carries a message from inside the brain. I caused this, nothing new here. Turn it down. Before your fingers ever reach your skin, your brain has already seen them coming.